Hi, in this video we are going to work on the cosine rule. So basically there is this formula including the cosine function, and this applies to each triangle, every triangle, right? So ignore this bit and you're going to have Pythagoras theorem. So basically Pythagoras theorem is a special case of cosine rule where the angle is 90 degrees. Now remember, cosine 90 degrees is 0. So a squared equals b squared plus c squared minus 2bc cosine 90, right? This bit becomes 0 and you end up with Pythagoras. Now, let's look at what the rule says. We have cosine of the angle A. So angle A is here, right? And B and C are the arms of the angle A. And across angle A is the side length A, right? So what happens is, every single time for the given angle, you have to leave the side length across that angle alone. So a squared here will be isolated, and this side is the one across the angle given, alright? And you always have the arms of the angle on the right hand side together with 2 times b times c times cosine A, right? So this bit is the angle, the cosine of the angle, and the arms of the angle. And we have across the angle that side length which is isolated. So let's see an example. Right. Calculate the length of the side AB in triangle ABC in which AC is 6.5, BC is 8.7, and the angle ACB is 100 degrees. Now you have to remember the triangles and the angles and the side lengths, how they are named, right? Because there is no visual here, there is no diagram here. You have to draw it on your own to figure out who is who, what is what, and what you're supposed to calculate. So let's do that. Now I drew an obtuse triangle because I have a 100-degree angle here. Of course this is just a sketch. I don't need to measure 100 degrees properly. Now, if you write ACB, then the middle letter must be here, right? That's the angle C we're talking about. Now, I'm going to go with the side length, AC. So let's say A is here, B is here. So AC here must be 6.5 and BC is 8.7. So basically we are asked to find AB, this side length, which is right across the angle given, right? So I can just use this cosine rule and go like AB squared equals, now it doesn't matter which is B, which is C here, as long as I use the arms of the triangle, right? So I'm gonna go like 6.5 squared plus say 8.7 squared minus 2 times 6.5 times 8.7. Well, this is not gonna fit in here obviously, and cosine 100. Right, so this is what I'll be calculating. Now just because I have the full sentence with no unknowns here, I can write everything on the calculator, right? But my suggestion is to go bit by bit, so it will be like this. So you calculate the squares separately, and then you calculate this bit separately. We know that cosine 100 will give us decimal place, right? So if you'd like, you can have this mid-step here. If you'd like, you can write the full sentence and write the answer, which would be So we have 137.579 and so on when you do the calculation. And this is AB squared. So I have to take the square root of both sides. Now this bit goes up to infinity. There's no harm writing 3 decimal places to be accurate enough to get the accuracy point, right? So we can go like the square root of this number will be AB 11.729, which you could round to 11.7. Now let's look at this example. It says find the size of the smallest angle in a triangle whose sides have lengths 3, 5 and 6 centimeters. So if we sketch it, it's going to look like this, right? So you have to know that the smallest angle has the smallest side across it, and the biggest angle has the biggest side across the angle, right? So in this case, we are asked to find the size of this angle. This means, all right, let's call it as alpha, right? Right. So according to the angle chosen or given, I can just write down my cosine rule. So across the angle will be the isolated one. So it's going to be 3 squared equals the arms of this angle will be here, 5 squared plus 6 squared minus 2 times 5 times 6 times cosine alpha. Now, if I swap this with this, right, I'm going to have, well, 2 times 5 is 10, 10 times 6 is 60, so 60 cosine alpha on the left hand side will be 25 plus 36 minus 9. And if I divide both sides by 60, and by the way, simplifying the top side, I'm going to have cosine alpha equals 25, 61 minus 9, 52 over 60. There I'm going to go like alpha equals cosine inverse of 52 over 60, which will give me 29.926, where I can round it to 1 decimal place, being 29.9 degrees. Generally speaking, the angles round up to 1 decimal place, but we hope that they are going to tell us in the question to what extent we are going to round the numbers. Anyway, so this is how we work the cosine rule to find the angle. You can see in the book and in other books that they tweak with the, say, cosine rule to end up with angle being equal to some other expression. To me, this is just memorization. We can just substitute the numbers here in the cosine rule itself and then manipulate it to end up with the angle equals to the inverse of cosine, right? You don't need to memorize formulas for this. Now, another example, right? Again, we have a triangle. There is no sketch. There could be diagrams, but sometimes there are no diagrams, so we just draw them. So basically, I will have a triangle ABC, right? So I go like, let's say this is A, this is B, this is C. It doesn't matter much which vertices will be A, B, C and vice versa, as long as you just write each expression or number properly. So AB is X, BC is X plus 2, right? And AC is 5. And the angle given here is 60 degrees. It is ABC, so it's this angle we're talking about. This is 60 degrees. Now the question is, find the value of X. Now you can suspect that there will be a quadratic equation in this, which you're right. So First of all, let's find the side across the angle given. It's 5, so it's going to be 5 squared equals x squared plus x plus 2 squared minus 2 times x plus 2 times cosine 60 degrees. Right? So if you start calculating this, well, it's going to take really long, right? Because it's going to be 25 equals x squared plus, if you expand x plus 2 squared, you're going to have x squared plus 4x plus 4 minus, now I multiply x plus 2 with 2x, so it's going to be 2x squared minus 4x, and cosine 60, cosine 60 is 1 over 2 if you check with your calculator, so I can go like 2 times, I can just distribute x to x plus 2, so I'm going to have x squared plus, say, 2x times 1 over 2, because now I'm going to have 2 and 1 over 2 cancelled. Now, if I go on, it's going to be 25 equals, well, I have 2x squares here anyway, so let me simplify it, plus 4x plus 4, and then I distribute the minus sign here, minus x squared minus 2x, right? So 2x squared minus x squared is x squared, and by the way, I'll take 25 to the other side, so I'll have x squared, 4x minus 2x is 2x, and I have 4 minus 25, it's minus 21, which is equal to 0. Now, this is the equation I am going to solve. Right, this looks like quadratic formula to me, so I go like minus 2 plus minus square root of 2 squared minus 4 times 1 times minus 21 inside the brackets divided by 2 times 1. From this calculation, I'm going to have minus 2 plus minus root 88 over 2. From here you're going to have the first x value to be minus 5.69 and so on, which does not make sense because we are looking for a side length, right? So let's check with x2, where I'm going to use the plus sign here. I will have 3.69 and so on, right? So I can keep it as 3.69, and well, the question does not ask anything else. This is the time to check what the question is asking. It's just asking us the value of x, which we have found. Now it could go like find the perimeter, and you can use area of triangle formula which includes the sine function. So it could ask the area of this triangle, right? So the next part of the question could be quite different, but here it's just finding the value of x. There are also bearing questions, but I'm going to go through these in another video. Right, so there is no online self-check for this because there's plenty of questions in the textbook, so please follow from the blog what you're going to do next. Thanks for watching.